This lesson is all about parabolas and seeing them as shapes, and how do we translate that into algebraic equations. So first off, the way we're going to think of the parabola here is a parabola is a special curve shaped like an arch with the following properties. Any point on a parabola is an equal distance from a straight line and a point. The line is called the directrix, and the point is called the focus. So these are important vocabulary words. We're going to look at some pictures to see how this works. The vertex of a parabola is the turning point. So this is our third vocabulary word. It is directly between the focus and the directrix. On the coordinate plane, the coordinates of the vertex are represented by the general point HK. So here's our first picture, and I kind of raised the complexity with each picture. So here, imagine that we don't have the parabola yet. We're just going to look at what's red. So we have a line and we have a point. The line is called the directrix and the point is called the focus. So finding points that are the same distance from both of them, this point right in the middle, what we would think is the closest to both the line and the focus, the directrix and the focus, that's definitely on the parabola. But then we have a bunch of other points. For example, I have a point right here such that these two distances are equal. And I have another point over here such that these two distances are equal. And the whole idea of how the parabola is defined is if I find all of those points that are the same distance from the line and the focal point, that creates the parabola. So if I'm all the way over here, this distance and this distance are going to be the same. Okay? So when we think of a parabola like this, it's almost like thinking of it like a shape like a circle. A circle is all the points a certain distance, which is called the radius from a center point. If you've done earth science and ellipses with planetary motion, that's all the points that have the sum of the distances from two focal points. Basically, you take a string and wrap it around those focal points, and that creates the ellipse. All of these shapes taken together, circles, parabolas, ellipses, and then something called a hyperbola, which we don't do in this class, are called the conic sections. So I'm going to look at the next picture. Actually, we'll read a couple things. In this picture, the directrix is above the focus. The parabola opens down, always around the focus. So the parabola always kind of bends around the focal point, we'll see, and the vertex is directly between them. And then we talked about this same distance and depth. So here's another picture. In this picture, the focus is above the directrix. The parabola opens up, always around the focus. Vertex directly in the middle. And then we see here those distance lines are drawn in, okay? And then one more vocabulary word we're adding in, which you have heard before. The vertical line is the parabola's axis of symmetry, so that just happens to be in this picture. This axis of symmetry, this line right here, doesn't really have to do with drawing the parabola, what we're doing in this lesson. But an interesting point is that the axis of symmetry always goes through the focus of the vertex, and it is perpendicular to the directrix. So here's our most complicated picture, still the same idea. This picture is on the coordinate plane. So we're going to be working towards this. In this one, we're saying that the directrix has an equation of y equals 1. So y equals 1. The focal point is negative 3, 3. So based on that, that means that the focus, which is right here, is directly between these two y values. So the y value between 1 and 3 has to be 2. And then because it's on that axis of symmetry also, the x value has to be the same as the focus. So the vertex is negative 3, 2. And then another thing that we're going to need once we start writing equations is what is the distance from the vertex to the focus. So in this case, when we go from the vertex to the focus, it's represented by the variable p. So from here, from the vertex to the focus, we had to go up 1, so P is a positive 1. So those are different things we find. As I said, this one's a little bit more complicated. We're going to look at a website quickly. So I just have to get this open in a different file, and we will look at that website. So here, if you look, it's showing how all those points, and you'll see D and D here. So that shows that the distance is the same. So that's how it's formed. And then here, let me just see if there's something else in this upload. This is another nice picture. And then this is showing those conic sections. So it's basically showing how you cut a cone. That's why they're called a conic section. You can make ellipses. You can make a circle if this plane is perpendicular to the cone. So it's kind of how they're connected. This is extra beyond what we have to do in class, but these are those different shapes that are called the conic sections. There's a couple other nice, let me see if we have one here. So this just shows different parabolas, which is not necessarily related, but we're going to be getting into the equations. Really the big picture you want to get is those equal distances, which is shown in this applet. And if we moved the focus, if I could move the focus up, it would change the shape of the parabola or move the directrix around, and we'll be doing those different things.